All right, so that's the nature of reality. Another one on the internet. There's a guy that freezes water, and it crystallizes. Probably seen it on YouTube. Japanese doctor or somebody. And he has this thing where he freezes water, and he has an intent. He gives happy thoughts, he gives bad thoughts. He plays pretty music, he plays awful music. And if he's happy and pretty, then his crystals that freeze in ice are very pretty and symmetric. When there's unhappy thoughts and terrible music, the crystals freeze in big globs and they're ugly. Okay? And he's done this and repeated it many times. Okay? So what's going on there? Does water like Bach and doesn't like acid rock? No, it's that the experimenter likes Bach and doesn't like acid rock. Intent, consciousness is the only active ingredient in all these things. So it's because he has an intent. It's his tension. There's a lot of uncertainty in how water freezes. You've heard that no two snowflakes are the same. It's because when water freezes, the crystalline structure has a lot of uncertainty in it. Well, you can modify that uncertainty with intent. Now, see, the problem is that because this is showing that the world is statistical and probabilistic and not objective. Science comes in with their scientific method that is just a subset and doesn't apply in these cases. And they go into Dr. Bill Tiller and they say, well, okay, give me that beaker of water and I'll do it. Well, it doesn't work. Well, there's a couple of reasons why it doesn't work. One is that they don't necessarily have the ability to have the intent to change anything. They're not that focused. The second reason is now there's a lot of intent going the other way. There's a whole lot of intent in this circumstance saying that'll never happen. That changes the probability in that direction, you see. So then poor Bill Tiller, he said, well, he's an idiot. He doesn't, that's not right. He's faking it. These things that all his data must not be true because we can't reproduce it and we know the world's objective. So if we can't produce it, then it's not true. And the same thing with this Japanese fellow. He's kind of been discredited and so on true because other people have tried to verify the experiment and it doesn't verify. But then he can do it whenever he wants. You see, that's where the understanding that the world is not objective and that it's just a subset. That's just a special case of the larger reality, is a subjective reality. All right? Okay. Let's go on. I'm getting close to the end. To render a virtual interactive reality, one has to define a virtual space. I'm going to get back and make the connection back into science, and then we're going to just kind of wind up with a few things at the end, so we're almost done. Imagine that these are little pixels of volume. Okay, on your TV screen, you have pixels, but they're area, right? Because you've got a flat screen, so they're area. This is our space. Our space is made up of pixels of volume. Okay. Now, if you're going to make a virtual reality game, there's one thing you really need to know is how big does the computer have to be and how fast does that computer have to be. And the way you figure that out is you look at how many pixels do I have, because each pixel has data, right? It's got color and intensity data. And how often do I have to update each one of those pixels? That tells you how much memory you need and how fast your computer has to be. This reality is the same way. So if we're going to spec this virtual reality that we live in, what we need to know is what's the pixel density and how fast do we have to update them. All right, so these are the pixels and how fast we update them. Remember that simulation? It goes by a delta t at a time. It goes through that outer loop. There's a delta t every time we go through it. Well, that's the refresh rate. And this is the pixel size. And if we have information that needs to travel through here, the information has to go from this pixel to this pixel to this pixel to this pixel, and it can only do that once a delta t. In other words, that's as fast as you can move information through this system. The information's here, one delta t later it's here, one delta t later it's here, and so on. The reason you have to do that is if you had information here and another delta t, it's over here. Well, that's what we call teleportation. Things just disappear in one spot and appear someplace else. In our reality, we need to have a buttoned-down virtual training reality that gives us a homogeneous isotropic space. If you don't have that, you live in a funhouse reality. So if delta t is not constant, then your time jumps around. If your delta v is not constant, your delta, your pixel, your volume pixel, then it's like a funhouse mirror. You take a meter stick, and it's a meter here, and you move over a different piece of volume, and now it's, it's a meter and a half because your pixels aren't the same. That's like an object going across your computer screen, and your pixels aren't all the same. It would distort. Okay, so we don't have a distorted reality because that would mess up the fact that we have this feedback. It's a reality you can depend on. So that is the way it works. Well, if delta v is a constant, so that we don't have a funhouse reality, and delta t is a constant, so we don't have a funhouse reality, you take the cube root of a volume, you get a distance. You divide that by a time, you get a velocity, and you end up with the speed of light, which is the fastest that anything can move through pixel to pixel to pixel, each in a delta t. So now what we've done is we've just used this idea of a virtual reality to derive why the speed of light has to be a constant. That, ladies and gentlemen, gives you relativity theory. All of relativity theory is based on that one concept. If speed of light's a constant, special relativity falls out as an algebra problem. See, that's the key thing. And right now, scientists would tell you that they don't know why c is a constant. They just know that it is. Okay, we also have shown that particles, of course, must be probability distributions. Everything is just in a future probability. It's just a future probable particle until you make the measurement. That's why particles are probability distributions. And today, physicists would tell you they have no idea why particles should be probability distributions. They just know that if they assume that, like Schrodinger did, they can get the right answer, you see. So this overarching theory that explains both quantum mechanics and relativity, you've just seen it, you see. This explains quantum mechanics and it explains relativity. Those are the two key things. So we've solved physics. We've done better physics here in that, by seeing that. Okay. All right, relativity theory is the logical consequence of C being constant. C being constant is the logical consequence of reality being digital and virtual. The magnitude of C represents a constant that specifies the demands placed on the virtual reality rendering engine. Okay? That tells the larger system how fast and how big a computer they need to do this. So the physicists search for the little toe that derives both relativity and quantum mechanics from one overarching understanding has been accomplished. So we can go in and finish now doing the big toe. But first, here's a summary of results. Again, modeling consciousness as a self-modifying digital information system that evolves towards states of lower entropy. That's our model. It's a virtual reality. Physical reality is a subset of virtual reality. The results. Physics and metaphysics become parts of one logical theory. Okay, what about metaphysics? Haven't we said that we're all one? Consciousness is the fundamental reality. We're all connected. Love is the direction we're moving to. It sounds like metaphysics, doesn't it? It sounds like something Lao Tzu or the Buddha might have said. This is where we're going. So we've done both of those. So Eastern philosophy and theology have been integrated with science. Love and spirituality are both defined in terms of entropy, a measurable quantity. Normal and paranormal are unified. We've derived a fundamental purpose of existence for us. Why are we here? To grow, move toward love, spiritual growth, lower our entropy, if you like to be more scientific about it. It's all the same thing. Okay, let's flip that over. Some additional results. I think we said most of these. One thing we didn't say is what's the difference between physical and non-physical reality frames? Nothing, only the observer's opinion. In other words, when you're in a frame, when you're in a reality frame, no matter where it is, let's say you're in the dream reality, it seems physical. When you're in this reality, it seems physical. When you're in an out-of-body state, it seems physical. And everything else seems non-physical. Whether reality is physical or non-physical is just the observation. It's just according to the observer. There is no fundamental difference between physical and non-physical realities. In other words, we can say they're all physical. Dream reality, this reality, they're all just as physical as each other, or they're all non-physical.